BYD built itself into one of the world's most formidable EV makers by mastering batteries, electric motors, power electronics, and mass production. Now the Chinese company wants to redirect those same capabilities into something entirely different: humanoid robots. BYD Executive Vice President Stella Li says her ambition is to put 2 or 3 humanoid robots into every BYD showroom. These robots could greet walk-in customers, walk them through vehicle features, demo the tech, and generally make the buying process feel more interactive. Li thinks the underlying technology could be commercially ready within a year or two, but the showroom is just the opening move. BYD is also building robots for factory floors, service industries, and eventually the home. The company is even weighing the idea of highly automated factories that could run with almost no human presence. That puts BYD on a direct collision course with Tesla. For years, Tesla has insisted it shouldn't be thought of as just a car company. Elon Musk has repeatedly framed Tesla as an AI and robotics company that happens to also build vehicles. Optimus, Tesla's humanoid, sits at the center of that vision, but BYD's arrival changes the shape of the competition. The next big fight between Tesla and China might not be about electric cars at all. It might be about which company can turn the auto supply chain into a robotics industry. Why BYD wants robots in its showrooms. A humanoid robot standing inside a car dealership sounds like a publicity stunt, but from BYD's angle, a showroom is actually a fairly practical place to start. The setting is controlled. The floors are flat. The products sit in predictable arrangements. The robot doesn't have to navigate a messy construction site or an unfamiliar living room. It only needs to handle a narrow set of repeatable tasks: welcome customers, field common questions, point out specific models, explain charging, and walk buyers through the available configurations. The robot also doubles as a live demonstration of BYD's engineering. Customers wouldn't just be looking at an electric car, they'd be watching batteries, motors, sensors, software, AI, and robotics all working together in one physical machine. Stella Li has been clear that robots won't replace human salespeople. Buying a car involves emotion, negotiation, trust, and personal taste. A robot can explain a spec sheet cleanly, but it can't really replicate the rapport between a customer and an experienced salesperson. The more realistic plan is to use the robots as assistants, letting them handle the repetitive explanations so human staff can focus on the questions that actually require judgment. Showrooms also give BYD a low-stakes place to run real-world testing. Engineers get to watch how customers react, which questions trip the robot up, where it gets confused, and how reliably it holds up over a full day. That data feeds directly into improving future versions before the robots get pushed into messier, less predictable environments. Why car makers are building humanoids. On the surface, a humanoid robot seems to have nothing to do with an electric car, but the two products actually share a surprising amount of underlying technology. An EV needs batteries, electric motors, power electronics, cameras, sensors, processors, software, cooling, and advanced manufacturing. A humanoid robot needs almost the exact same list. Its battery stores energy. Electric actuators drive its arms, legs, hands, and joints. Cameras give it a sense of its surroundings. Processors interpret what it sees and coordinate its movement. Software decides how it should react. The physical form is different, but a huge amount of the industrial know-how carries straight over. That gives EV makers an edge over pure software robotics startups. A robotics startup might have great AI, but very little experience actually producing complex hardware at scale. A traditional automaker already knows factories, suppliers, quality control, logistics, safety testing, and cost-cutting inside and out. BYD has an extra advantage here because it builds so many of its own components in-house. The company started as a battery manufacturer before it became a major car maker, and along the way it built up deep expertise in battery chemistry, power semiconductors, electric drivetrains, electronics, and automated manufacturing, all of which can be redirected toward robotics. Before a robot can move out of a lab demo and into an ordinary business, it needs to get cheaper, more reliable, and easier to manufacture. That's exactly the kind of transition where big industrial companies tend to have the advantage. From car factories to dark factories. BYD's robot ambitions don't stop at customer-facing showroom bots. The company also wants humanoids on its own factory floors. Manufacturing is one of the most obvious early markets for these machines. Industrial robots already weld car bodies, move parts, apply paint, and handle other repetitive jobs, but most of them are bolted in place and built for one single task. A humanoid, in theory, could move between workstations and use equipment that was originally designed for a person. It could carry parts, inspect products, run tools, or handle jobs that shift from one production run to the next. That flexibility is the whole pitch. Instead of rebuilding an entire line around a specialized machine, A company could just train a general-purpose robot to work inside an environment already built for humans. BYD has floated the idea of dark factories within roughly 3 to 5 years. A dark factory is a facility so heavily automated that certain areas could technically run without normal lighting. That doesn't mean every worker disappears. Maintenance, engineering, supervision, safety, and quality control would likely still need people, but the production floor itself could end up far more automated than a typical car plant today. Humanoids wouldn't be working alone in there either. They'd operate alongside robotic arms, autonomous transport vehicles, machine vision systems, and smart production software. The end goal is continuous manufacturing with fewer stoppages, lower labor costs, and faster adaptation between production runs. Tesla's Optimus vision. Tesla spotted the link between EVs and humanoid robots earlier than almost any other global automaker. It unveiled Optimus back in 2021, pitching it as a general-purpose machine built to handle dangerous, repetitive, or tedious work. Tesla's long-term bet is that physical labor is an enormous market. If a genuinely useful robot can work across factories, warehouses, offices, and homes, demand could eventually dwarf demand for cars themselves. Tesla argues its EV experience already hands it most of the necessary building blocks. It designs batteries, motors, power systems, computer hardware, cameras, and AI software, and its own factories give it a controlled place to test robots internally before ever selling them externally. Tesla has kept building out production capacity for Optimus, though the timing and scale of full commercial manufacturing are still up in the air. Humanoid robots are much harder to mass produce than a slick demo video makes them look. Walking across a stage is nowhere near the same as doing useful work for 8 straight hours. The robot has to balance, recognize objects, manipulate tools, recover from its own mistakes, and stay safe around people. The hands might be the hardest part of all. Human hands combine strength, sensitivity, flexibility, and extremely fine control all at once, and a useful robot has to handle delicate objects without dropping or crushing them, doing thousands of movements without breaking down. Tesla may have a head start in public attention and development time, but it's clearly not alone in the field anymore. China's robotics ecosystem. BYD is stepping into one of the most competitive robotics markets on Earth. China already has a dense web of companies making electric motors, actuators, sensors, batteries, gearboxes, cameras, and industrial robots, many of which grew up alongside the EV industry. That gives Chinese humanoid makers a massive domestic supply chain to draw on. Companies like Unitree and UB Tech have already turned heads with walking robots, factory pilots, public demos, and increasingly capable platforms. Another EV maker, XPeng, is gearing up to mass produce its iron humanoid by the end of 2026, planning to deploy it in retail stores first before expanding into wider commercial use. Its CEO has personally taken the reins of the robotics division, a sign of just how strategically important this has become. XPeng is also folding humanoids into a broader physical AI strategy that spans autonomous driving, robotaxis, and even flying cars. A pattern is emerging here. Chinese EV companies no longer treat the car as their final product. They see it as a platform, one that's already handed them expertise in batteries, motors, sensors, computing, factories, and AI. Robots are simply the next platform in line. Why humanoid robots are still hard. The investment is real, but the technology is still immature. Humanoid robots look impressive in a carefully staged demo. Real commercial environments expose their weak points fast. Battery life is limited. Motors run hot. Mechanical joints wear down. Hands fumble with unfamiliar objects. Software can get thrown off by sudden movement, bad lighting, noise, or a crowded room. A human worker adjusts instantly when a box ends up in the wrong spot. A robot might just stall out completely. Reliability matters even more on a factory floor. A machine that works 90% of the time can look like a success in a short demo, but a 10% failure rate on an actual production line is a deal breaker. Every stoppage ripples out and slows down the rest of the facility. Safety is its own hurdle too. A humanoid is heavy, powerful, and built to move around people, so its software has to prevent collisions and react correctly the moment someone steps unexpectedly into its path. Companies also have to ask whether a human shape is even the most efficient design in the first place. Humanoids make sense in spaces built for people, but specialized machines can often be cheaper, faster, and more dependable for a given task. A warehouse might do better with wheeled robots than with ones walking on 2 legs. A factory might still prefer fixed robotic arms for repetitive assembly work. Humanoids have to prove their flexibility is worth the added complexity. The economics will decide the winner. This race won't be won by whoever posts the most impressive video. It'll be won by whoever can deliver useful work at a competitive price. Businesses will weigh purchase price, maintenance costs, energy use, reliability, output, and expected lifespan against each other. A cheap robot that needs constant repairs might not actually save any money. A pricier robot could still be worth it if it runs continuously and covers several different jobs. Manufacturing scale will matter enormously here. Both Tesla and BYD know how to drive costs down through volume. Negotiating with suppliers, redesigning parts, automating assembly, spreading R&D across huge unit counts. China's broad manufacturing base could give BYD cheaper components and faster supplier competition, while Tesla may lean on stronger AI branding, years of robot development, and tighter integration with its own software stack. The winner probably won't be the company with the most human-looking machine. It'll be whoever hits acceptable performance at the lowest total cost. What this means for Tesla: BYD has already pushed Tesla hard in the EV market through aggressive pricing, battery integration, fast product cycles, and manufacturing scale. Humanoid robots could follow the exact same script. Tesla sets a bold vision and grabs global attention. Then Chinese manufacturers catch up through faster industrialization, denser supplier networks, and lower production costs. That said, BYD's success here is far from guaranteed. Building cars doesn't automatically translate into solving robotics. The company still has to nail sophisticated AI, reliable hands, safe movement, and genuinely useful software, and it still has to prove that showroom and factory robots create real economic value. But BYD doesn't need to beat Optimus right out of the gate. It just needs a working platform, a place to test it internally, and the repetition to keep improving it. Its showrooms give it public testing ground. Its factories give it industrial testing ground. And its dealer network could eventually turn into a sales and service pipeline for robots too. Put together, that's a genuinely powerful combination. My take: what stands out to me about BYD's showroom plan is what it reveals about how the company plans to ease into robotics. Gradually, not all at once. It isn't opening with some impossible promise of a robot that can do every household chore. It's starting inside controlled spaces where the machine can deliver limited but visible value, and from there it can graduate into factories, then eventually into services and homes. Tesla is following a similar path, testing Optimus inside its own operations first. The difference is that China now has an entire ecosystem chasing humanoid commercialization at the same time: BYD, XPeng, Unitree, UBTech, and a long list of component suppliers, all competing, learning, and driving costs down together. That could speed things up faster than any single company expects. The EV race already proved China can turn an emerging technology into a full-scale manufacturing industry. Humanoid robots might be the next test of that same playbook. So, what do you think? Will BYD turn into a real competitor to Tesla in humanoid robotics, or are showroom robots still more marketing than useful technology? Let me know in the comments, and subscribe to Eastern Engine and hit the notification bell. This is where the actual story is: the factories, machines, batteries, and engineering decisions reshaping the global economy. Because BYD might still be known as a car company today, but its next major product could be the one that walks into the showroom on two legs.